Hi, nice to see you. Hi. So thank you for accepting our invitation. Thank you for connecting with us. Everyone who cannot be at this time, but with us live, we're gonna send the recording, so everything is gonna be fine. Today, a short topic, but I think it's a very, very powerful topic. It's the smile analysis. When you design a smile, everything could be fine, everything could be in the right place and in the right angulation, but it's better when we have a tool to check all the studies and all the angulations and everything in an automated way to find out every single detail and then to correct everything. And that's interesting, because from a nice smile we can create something that is very, very cool. Just a second. So in our update, because our update is always on the way, I today I added something that it was very clear. It should have been, but I didn't think about it. But now I just integrated, and let me show you. So in the next update that we will have, we integrated the facial thirds. Facial thirds, edentulous patients, beautiful. You set the lines, you have the facial thirds, and then you know where to start with putting a smile in the face. Facial thirds analysis, super, super easy and automated, and then you can play. And when you have edentulous patients, then you can start with the position. But in our normal smile analysis, we have a lot of stuff and all the studies that are super, super cool. Really 40 years of studies in aesthetics, and everything is in here. So let's start with the top option, smile proportions. We do have in the smile proportions, we have the golden proportion and the red proportion. We use the red proportion as a standard, but you have patients, the red proportion just doesn't work. So you can move the slider to the golden proportion, you see, and then you have the midline and the golden proportion. The red proportion is more, it's working more in my experience than the golden proportion, and it gives you a way to analyze the face and to put the new smile. Because if we design canine to canine, which is the smile design, then we have the 1. So the central should be 1.6, 1, and 0.6, right? These are the proportions. That's the red proportion, and it's actually a beautiful way to check and to see, if the teeth are matching these lines and the proportions to get this facial harmony that you want to get. If you have the centrals, always the centrals, they need to be the same width. Laterals, canine, they have to be maybe different because of the angulation of the teeth and everything, but the centrals should be the same, because the centrals, when you look at the centrals, they should be exactly the same embrasure, same size. For that one, you go to tools, you select a central that you like the size, you like this, and then I reflect, you see the size and everything on the other central, and now both are the same. The new option that we have, all, when you click on a tooth, you see you have rotation, you have a rotation in all directions, and you have size. Oh, I need to link the size, so let me redo again. So now you can rotate. If the link option is on, you can rotate. It's linked right and left side. You can resize. Both are the same, you see, like this. And you can move them up and down. Good. So the smile analysis, I messed up here now. The size. So let me. Now, what is important when we start with the smile analysis? When we start with the smile analysis, we actually need to analyze first the templates that we use for our patient. What do I mean? When you go, for example, to the scan of the patient, right? And we analyze here the scan of the patient, you see the centrals are pretty, the buccal surface is pretty straight. So you can use, for that case, a template that has a buccal surface that is round, and you can use a buccal surface that is flat. You cannot use this kind of template with a straight buccal surface on a patient that has a round buccal surface, because even the prep is going to be round and then your template is straight. So it's going to be very hard to find, to match, to cover the buccal surface, and you will be forced to deform the tooth in a very, very ugly way with deformation tool and all the stuff. And the incisal edge is going to be too thick, too big. It's not going to look good. So you analyze the patient, you analyze the templates, and then you use the templates that match the actual form of the buccal surface of the patient, right? So like this. Now, let's correct a little bit here the position and everything. That's like this. Now, our design can be, when we design a 3D, our design can be motivational mock-up, additive. So everything needs to be covered by the new design needs to cover patient's teeth. Ideal design, which can be subtractive and additive. What does it mean, subtractive? Subtractive means that we want the teeth in the ideal position, and all these areas that we see through the tooth needs to be prepared. The areas need to be prepared, needs to be reduced to make space for the veneer or the crown, whatever you do, right? So that's an ideal design. When we want to design something ideal, then we just put them in the ideal position, and then we see the areas that need to be prepped, reduced, or modified, right? So that's like the ideal design, because we follow an ideal curve, and we see, oh, okay, this tooth is actually not in the right position. We need eventually ortho. We need to correct the position of the initial teeth. The centrals, in this case, they are very, very straight, right? Very, very straight. So also for the smile analysis, the question is, do we want to keep, because a lot of smiles, they have the centrals very, very straight. You see, frontal, they are all frontal on the line, or we reconstruct the occlusal curve and we put them in a curve. That's now a decision that you need to make. And of course, ortho in this case is also an option, and very, very visual, to explain to the patient why you need to start with ortho, you know, to bring them in a better position. Like, for example, this lateral is not following the occlusal curve or the smile curve, so we need to make it more like this, right? But now we see, when we have an ideal design, when we follow a certain occlusal curve that we reconstruct, we see that actually the lateral, the position of the lateral needs to be corrected, and also the central. If it's prep, then needs to be reduced, and then we get the new smile. So for the ideal design, when we look at the position of the teeth, we may say it looks good, it's not bad. But let's analyze now with the automation and AI. Let's analyze the smile and see if everything is really properly set. The model is frontal automatically when you select the smile analysis. Then we have the proportions. We discuss the proportions. And then let's select the zenith analysis. The zenith analysis, we set the points on the highest level of the gingival margins, canine, lateral, central. Like this. Now, we do have two triangles, right and left. You see, two triangles. That's in the book of Galib Gurel, also described for the natural smile and the smile analysis. Now, just imagine if the patient has a gum recession on the canine or lateral. These two triangles, they are completely different. So let's analyze. We do have the distance between the central and the canine on the right side is 16.1. On the left one is 15.5. It's 0.6 millimeter, not so bad. If the patient would have a gum recession and this point would be up there, then you have maybe 19. And then you can show to the patient visually, these two triangles have to be as close as possible. This is 16, this is 19, because you have a gum recession. Instead of covering your gum recession with a veneer that's so high, which I see very often on social media, we're gonna do the surgery on your gums. We're gonna correct the gum line, heal your issue, and then we will create these two triangles as close as possible together, because then we have a symmetry of the gingival margins of the canine, laterals, and centrals, a symmetry that creates these two triangles, and these two triangles are beautiful. Also, it shows you if your design is created, for example, with if you want to do gingivectomy, for example, right? You still can check if the gingival margins are not on the line. They need to create the triangle, because sometimes the gingival, the central, the lateral, and the canine are on the line. All these 3 points. It doesn't look good. With this option, you can analyze and you can make the decision for the treatment plan. Good. Zenith analysis. Then the ideal design, the axial angulations of the teeth. Even if my smile design looked good, let's say I didn't see big differences, the axial angulation is automatically calculated. This canine is 5.4, this one is 4.3. So the axial angulation of the canine is not the same. If I like this one, you see this canine is more out. So I select this one, I say that's the good angulation, and I transform let me go back. Rotation. So I like this one. I select the canine and I transfer the 4.3 degrees angulation on the other canine, on the right canine. And now my canines have the same axial angulations and they look more in harmony with the same angulation. Same for the lateral. This one is 2 in. So this one looks better. I click on it, I reflect 6.2. Now both are the same. Centrals, I need to be careful with the centrals because I need to compare and to check, you know, what looks good because the centrals are the most important part of the design. And when I see the centrals and they are symmetric and beautiful, and the axial angulation is the same, and the embrasures and everything looks symmetric, then it's a beautiful way to to start the smile. Also, you see the incisal angulation between the embrasures, central and canine, the same, right? The same, because we have the same axial angulation. And now my smile is much more in harmony in the relationship between every single tooth. That's the ideal design. So the ideal axial angulation. Good. I can set, you see, the smile in the face like this, and then check my my smile in the face, because it's a facially driven smile design, so it has to be good in the face. Why it's important, what I mentioned, the centrals, because even if we have the axial angulation on the model and it's the same, if the smile is canted in the face and you need to change the angulation in the face to make it look good, then the axial angulation is not going to work, because sometimes the lip or the face or even the occlusal plane is canted. But if you want to create the centrals, for example, straight to the face, so that the centrals are not canted, then you need to break, right, the rule, and actually to make it work in the face, So everything what we have is a proposal, is a good start, is a way to analyze the smile, but at the end you need to see the face, because if you see the face and everything is fine based on the rules, it's good. But if the chin, for example, or the occlusal plane is canted, then you need to follow the facial flow, for example, right? The facial flow, and you need to, if the facial flow would be like this, so the lower third of the face goes like this, and the smile is canted, then you need to follow the facial flow and to create the smile that should follow the facial flow, instead of creating a smile that is straight in a canted face, right? It doesn't look good, because then the gingival margins are going to be different. The distance from the incisal edges to the lip is going to be different, to the lower lip is going to be different, and then it doesn't look good. So we have rules, of course, but exceptions for the facially driven smile design. We need to check the face and to adjust everything to the face. Good. So what do we have more on this facial analysis? We have the ratio. You click on the ratio, and then we see the ratio. You see between, oops, I need to lock the model. So we see the ratio, and we try to get the ratio should be the same for both centrals, right? Ratio means the height is 100%, the width is 83%, for example, or 100 to 80, or 100 to 70, or 75, whatever it is. But we need to make sure that both centrals have the same ratio, and with this option we can check and we can do the ratio. If we want, for example, to go with the ideal ratio, right? Ideal ratio would be 80, 100 to 80. And I say, you know what, we're gonna redesign and make it work for 80. Good. So I set the box to 80. Now I have a visual reference for my tooth, and I change the size to 80. You see? Now this central is 80. It's a tool to make it work, and to check if the ratio is fine. Good. So that's the ratio. If you click on measurements, then we have the opacity goes immediately 50%, and now you can check you can measure and say, okay, 2.1 millimeter, it's gonna be the new incisal edge. So you can make some notes, or you can make some documentation about the design and how the design changes based on the new length of your incisal edges. These are the measurements, and that's the smile analysis. Now we do have the axial angulations, we do have the zenith analysis, we have the facial flow included, right? We have the smile proportions, and now this smile is way better balanced to the face with this kind of analysis. The reference lines are also important because I want to make sure that my centrals are on the same height. So let's go full screen, and I like frontal, okay? Oops. I messed up. Good. So with these lines, I can make sure that my centrals are on the same height. They are not. So now I can go and bring everything. You see the laterals, this one is too high, and the canine, this one is too high. Now with the reference lines, I have also my smile on the same height. And let's see how now everything looks like in the face. All these tools, again, visual references, automatic calculations to make sure that everything what we have is in harmony, is straight, is symmetric, is beautiful. Because I see many cases, and I don't like, for example, when you see a canine is like this. A canine is out, one is in. There are small details in a smile that you can correct, and you can make sure that everything is fine. If you have, of course, a lab technician with a huge experience, 10-15 years, they have the eye for every single detail. But we don't work 8 hours on creating design like a lab technician, so we need tools that calculate for us and help us actually with all these details in the smile. So now the occlusal curve is good, everything is pretty fine for my smile. Liquify. I go to Liquify, and we're gonna have in Liquify, it's already in the live version. We do have the Liquify. Let me check what version do I have, because sometimes I have, oops, sometimes I have prototypes that I show you, and it's not the live version. Okay, let me open a different case. Okay. Oh, that's not even my account. Okay. That's why. Let me open. So in Liquify, the next update is gonna be with a new functionality, and I think this functionality is really powerful, and we made it very simple. So I want to show you this this new functionality of Liquify. So you have a tooth, right? But this template is pretty solid. It's a template that we use, and you have limited options to deform the template, to make it different. So, but with the new feature, with the new update, if we want to change the embrasures, I select the top point, and now look what happens. Both top points are linked and symmetrically change the form of the tooth. So I can make it more triangular. I can open the embrasures. I can close the embrasures on both sides, right? So I can, if I like a template, but this template is too round, and on my patient, I need the triangular form, I can do it now so easy. Look, I select the top points, I bring them in, I change the form. Now I go gingival with the arrow, I go gingival, you see? Okay, too much, I come back, and now I have a clean gingival margins. And this feature is going to be also super important for veneers and the prep margins, because you have the design and you want to redesign for the prep margins and adjust the design, so you can take the point and adjust over the margins. Here also, I don't like, maybe I like the form, I don't like the embrasures. My patients want round incisal edges, or the embrasures a little bit more round. Super easy to select the points and to change the template to make it more, you know, in the aesthetic feature, to make it more customized. And the number of points, I can vary the number of points from 3 to 5. You see, now I have, so the template is divided in 5 points, lingual to buccally, and mesial distal, 5 points. So now I have a lot of areas that I can change and modify and make it very, very precise. Very precise. So, and then you can select the symmetry option, and then when you want to create your centrals more triangular, you can change both centrals at once or both laterals at once. So you just click the top points, and then both are changed, so you get the symmetry for the centrals or for the laterals regarding this design. Please, yeah.
Hi, Rob.
Let me know.
Thank
Hi.
you. Great
Nice
presentation. My question is that, let's say if you choose the to adjust the form of the laterals, do you need to somewhere link those laterals together so that if you change one, the other one change?
Yeah, that's the symmetry option.
How? Where do you? Where is that option?
Let me share the screen. Oops. Here. Here, symmetry.
Okay, got it.
You know, and then you have both canines, laterals, centrals, and then multi-selection. Multi-selection is the option. For example, if you want to select canine to canine, canine to canine, then you can select all 6, and then you go to the incisal edges, and then you push the, let's say, incisal distal. You push them up, and then all of them became more round, the incisal edges. Or you can push them out or in, buccally lingually, you know, and then you can change the form. So you have a lot of options to really go into very, very small aesthetic details and change them very, very easily, because that's the problem. If the tool is so complicated, it changes the form of the tooth, but nobody can work. You know, I don't know, I think Planmeca, or I don't even remember, somebody had a tool to create molars, and there were some really super talented artists, and they created like design molars, you know, with every single detail on, like a sculpture. But these guys are, but these guys are 2 in the world who can do all this beautiful stuff. So what about us? You know, so we need to create something that is so easy, that allow us to create beautiful stuff without working for years, you know, only on one feature.
They don't share it with everybody.
Yeah. Okay, let me see if we have some questions. Oh, I see. So here, okay, I see the picture that you send in the chat. So I think your problem is you didn't calibrate the picture with the intraoral scan. You know, you didn't Almira. Yeah, so you need to calibrate the picture with the intraoral scan first. So go back to calibration in the case management. Go back to calibration, click on calibration, and then calibrate the picture with the intraoral scan. Or you can share this case on support, and I'm gonna record and calibrate for you, and then you see, because that's the first step, the important step. The intraoral scan has to be calibrated with the picture, otherwise it's like this. Okay. Good. So if you don't have any questions, thank you so much for attending. We will send you the recording. And if you have a topic that you want me to discuss next time, please send us an email and say, we have a topic.
Raf, I had a
record.
question.
Yeah.
A small detail.
Yeah, sure.
Would you recommend to use the SmileFy to adjust everything closer to before, let's say, and then in the end go to mesh and adjust the margins? Or it's better to make sure the margins are correct and then come back and then with the SmileFy change the shape? You do first.
Okay, so the first thing is, what I recommend is the design has to be clean. So don't try to correct the design with SmileFy or with the mesh editor, because the design should be actually clean from the beginning. So the position of the teeth and everything. SmileFy is gingival margins adjustment, very easy, and interproximal contacts, AI interproximal contacts, very easy. One click, adjusting the contacts, saving. Mesh editor is, you can do the same with mesh editor, but it's more complicated than SmileFy, and you cannot correct automatically the interproximal contacts with mesh editor. But in the mesh editor, if you have a mockup, then you delete with mesh editor the palatal area, and you let only the buccal additive design.
So where the mesh editor is mostly to delete the extra excess stuff.
You can delete the extra. You can do it in SmileFy too. If you turn the model occlusal plane and you select a point in the occlusal view, then you can reduce this volume and then correct. But SmileFy mesh editor has more stuff, so you can.
But it's easy to distort the tooth with mesh editor.
You distort the tooth and you can break a lot of stuff. SmileFy is more safe, because if you select, for example, I open the case now. If you select a point in the middle of the buccal surface and you drag it out, you can create a more round buccal surface, very, very easy, preserving, the
secondary anatomy
of the tooth. Gingival margins, very, very easy to be adjusted. In mesh editor, you can do also with all the brushes stuff. It's more complicated. If you train with the brushes, then you do 2-3 cases and then it's fine. It's more simple with SmileFy, and we don't have in mesh editor. So mesh editor is actually just the tool where you can, for example, simulate a gingivectomy. You can correct the gingival margins. You can do the post-op design, reducing the meshes. And mesh editor has very powerful features. I don't know if you remember, where you select, for example, we had a case composite veneers, really ugly. So the patient wanted to come once, remove the composite veneers, and have a new design. The problem was, if you do stuff on the mesh editor, let's say like this, maxilla design. If you want to reduce digitally, delete the composite veneers digitally, there is no tool in the world that protects actually let me show you. Let's do something else. Let's select the mesh editor only with the maxilla. So let's say that's my design, that's my scan. I want to reduce the composite veneers and redesign in one appointment. I have the scan, the patient wants to have the composite reduced and the new design done in one appointment. So what do? If I go here and I select edit model, right? And I select, for example, flatten. If I start now flatten the tooth, you see, I destroy the gingival margins.
Yeah.
So I cannot destroy the gingival margins because I need them for the new design. But mesh editor, what I can do is mark area. I mark the area with a brush like this. I invert the selection, and now I click reduce area. And now look what happens. If I go with my brush over the gingival margins,
it's not gonna
change because the gingival margins are, you see, I go with the brush, nothing happens. But if I go over my tooth, I can reduce these composite veneers. You see, I reduce them, and the gingival margins, look, no matter what I do, they remain the same. So I preserve the gingival margins, and now you see,
I can see
the veneers, the composite veneers can be reduced and they're gone. And now when I design on top, if I reduce them, if the patient comes back into the office, right, and you take the composite veneers out, you have already the design. So you can create a new silicone key, create temporaries for the patient, goes home, you have the same gingival margins, a new design, and done. Otherwise, what do you need to do? You need to scan, take out the composite veneers, scan the patient, and do the design, maybe in 1, 2, 3 days, and then the patient needs to come back, but the patient has now the teeth removed. So we want to reduce and to organize a little bit better so that you have only one appointment.
So with mesh editor, we can do virtual prep.
Yeah, exactly.
And get and then design the teeth, and then print the model, take the silicone stain. Now we are ready for provisionals.
Exactly. And that's one appointment, and it's very convenient. So, and then people told me, oh, we need 3 tools to do all this stuff. And then I worked one night and I created this feature, and it's super powerful because now the tooth is gone. The composite veneer is gone. We have the gingival
not only composite veneers, right? We got there are some crowns that patients have.
Everything.
Effective crowns. Do you know that if I remove this crown, I will have only like a small tooth, so I can digitally
exactly
the mesh.
Reduce and redesign.
Okay. Thank you very much. It was very informative and very useful.
It was a pleasure seeing you again.
The pleasure is all mine. Are you in your boat, Ralph?
Yeah.
Nice.
In Mexico right now. Just came back from Belize. Was diving in Belize, and now we are back in Mexico.
Oh, you're diving, like scuba diving?
Yeah.
How deep have you gone?
Oh, I stay at like 50 meters, so 45, 30 feet, not more than that.
Did you say 50 meters? Like
15, 15. Oh, okay. Yeah.
Because 50 is like a serious.
No. These are professionals.
Yeah. Nice.
professionals, and then you need a lot of time to come back. You need
Yeah.
10, so I don't know, like
Yeah,
20
but
feet or so, and then you need to wait 10 minutes, and then or
yeah,
5.
because the oxygen is not enough. Even they take helium in there, and it's usually not enough for 50 meters.
Oh no, it's not the oxygen. It's the you need a lot of tanks, but what you need is the I don't know what happens, with the blood when you come.
Yeah. When
pressure.
you need to wait a
Yeah,
minute every couple of meters.
yeah,
You need to
yeah.
wait until you're yeah. So
So I go on the
you
safe
come too
side.
close, you will have embolism when there are some bubbles
Yeah,
in your blood.
exactly. The bubble. So
Yeah.
I make it fun, not too deep.
Yeah.
So
Not too risky.
no.
It's wonderful. It was great seeing you. Thank you so much.
Thank you.
We'll
Thanks.
see you
Bye-bye.
next week.
Yes, and please, if you want the topic, please send us, proposals, and then I'm gonna talk about everything.
Okay.
Okay.
Thank you. You
Bye-bye.
have a good one. Bye.
Thanks. Bye.